I am Harshvardhan and my lab partner is Archit. We are going to present the Lab 8 which deals with the modeling of forest fire spread under different rules and circumstances. The deliverables of this lab are: we will consider the fire spread model with an initial density of trees with a small fraction of them burning. We see how the initial density of trees and the burning probability affects the final result. We have considered the case what happens if tree takes 2 time steps to burn down. Next, we consider that a tree catches on fire from neighboring trees with a probability proportional to the number of neighbors on fire. Lastly, we have included the wind factor in our model. The assumptions that we have considered are: model is a discrete state cellular automata model, forest is assumed to be grid, von Neumann neighborhood, periodic boundary, value constant meaning 0 represents empty, 1 represents tree, and 2 represents burning tree. Immunity of tree is taken into account. Let us move towards the visualization, observations, and results. Here is the simple visualization of the forest fire spread. Probability that there is a tree is 0.7 and probability of initial burning tree is 0.002. Immune probability is 0.2. Here is the simulation which runs for 60 seconds. This figure shows how forest initial density determines the final density of the trees. We observe when the initial density is high, more trees are in contact with each other, therefore more trees will get burnt, as a result of which the density of trees decreases drastically with time. In the case of low initial density, forest will retain much more trees after the simulation ends. This figure shows if the initial density of tree is increased beyond a certain point, then it will lead to the whole forest burning down. This point is known as the tipping point. In this case, we make a change in rule. That is, a cell gets burnt only if its neighboring cell is burning and its probability is considered in this case is 0.5. Initial entire forest is covered with tree. Only grid cell 8,8 is burning initially. Here is the visualization for the same. From the figure, we infer that as the probability of burning of a cell, if a neighboring cell is burning, increases, then the fraction of forest burnt will also increase. Also, the time required to burn a particular fraction of forest increases.
Here we will Here we will consider that each burning cell will burn for 2 time step before becoming an empty cell. By doing this change, we observe that the probability of burning a cell increases and the forest will get destroyed a lot faster. Here's a visualization for the same. The following figure shows how forest initial density determines the final density after 3 for 2 time step. We observe that a dipping point comes earlier than in the case of 1 time step stimulation, and the forest get burned down a lot earlier. Here we consider that a non-burning cell with tree will get burned depending on the probability of its neighboring burning cell, that is north, south, east, west cell divided by 4. Here is a visualization for the same. Now, in the next two cases, we will be analyzing the wind effect on the forest fire spread. We have considered that the wind is flowing from north. Also, here the wind level low by introducing a rule. The rule is that if a site contains a tree, then it can burn if it is not immune to fire, and if the cell in its north direction is burning. Here is a visualization. Here we have kept the wind level high. The rule is same as the previous case with an extension that the cell south of the site will also burn depending on the humidity level. The same is applied if the wind is flowing from west, east, south direction. Here is a simulation. By analyzing both the wind level, we observe that a high level wind does more destruction in comparison with the low level wind flow. So here's the conclusion of for our lab. Initial forest density determines the final forest density. Higher the initial forest density, more will be the destruction. If initial density is more than tipping point, then almost entire forest will be burned down. A tree getting burned down in 2 time steps will lead to severe and faster forest destruction. If a tree burning depending on the neighboring cell, then it will cause more severe destruction. However, the spread is relatively low as the probability of burning neighbor increases gradually. A high wind level will affect the forest more than the low wind level. That's all for the lab 8. Thank you.